Right, over here, we're going to learn a multiplication of probabilities for independent events. What are independent events? Independent events are like, if let's say I have event A, getting a tails from tossing a coin, and I have event B, get a 6 from rolling a fair die. So ask this question, when I toss a coin, does it affect the outcome probability of rolling a fair die? No, correct? They are two independent events. So right now we will ask ourselves why we want to multiply. So before I come to that, let's take a look at the tree diagram, and we realize that we have the heads tail first event, and event B second event we have the rolling of fair die 1 to 6. And if we list out the outcomes, we have a total of 12 possible outcomes. And if we want the tail 6 is 1 out of a total number of 12 possible outcomes, which gives us 112. So then you ask yourself, why multiply? So if we will put down the fractions, right, on the branches, so I know getting a heads and tail is equal chance. So I get half and half. Likewise, getting a 1, 2, 3, 4, 5, and 6, each of them have an equal chance. So it's 1, 6, 1, 6, 1, 6, 1, 6, 1, 6, 1, 6, and for the rest also. So right now, if we follow the branches exactly, right, we realize that the tail 6 is actually 1/6 of the half branch. So we realize that when we have probably event A and B, I can actually do half multiply by 1/6, and what do you get? 112. It's exactly the same as what we did just now. Do you see the matching portion? 112, 112 when we list the possible number of outcomes. So actually we are finding a fraction of a fraction, and realize that this matches our list just now, where we have 1 out of the 12 total paths that we have. So multiplying is just a shortcut for listing out the outcomes. So to summarize, whenever you have probability event A and event B, we will do probability event A multiplied by probability event B, and this is very important. You must take note of this.